Here, we will address training anomaly detection. To train an anomaly detection model, add the action to your workspace. To do that, either select from the recommended list of actions or go to General Actions and select Train Anomaly Detection. When the Train Anomaly Detection action is on the screen, open it up and you'll see that you have several inputs that you can specify for training anomaly detection. And the whole point of training anomaly detection is to find, through an unsupervised approach, what are some unusual transactions or some unusual records in your data set that may be different than others in a way that causes some sort of suspicion. They are anomalous in some way or another based on some of the inputs that are available. There are different models that allow you to do this. I'm going to choose some from a number of different types, or I could select all or something called ensembling all. When I ensemble all, I'm using many and then combining them in a specific way automatically. So either choose anomaly, ensemble all, or select all if you're not sure which one of these is best for you. Segment columns are like other segment columns. If I wanted to do a different anomaly based on smokers versus non-smokers, it's available. In this case, I'm not going to do anything different. In the advanced settings, I'm provided with settings for the specific modeling actions that are available to me. I can choose a different selection metric for an automatic evaluation metric for the best model. I'm provided different levels of strictness. How strict do I want to be? I'll leave it at normal, and I can choose the features that I want to use. Since I'm not doing anything with advanced settings, I'll leave them as is. I'll click Save Changes and Execute. When the anomaly detection models are done executing, I'm presented with some results. I have results for the different modeling techniques that were selected, as well as any segments that were selected. I have a count of the total number of anomalies in the data set and some other metrics that allow me to evaluate the success of my anomaly detection. The goal of anomaly detection is to identify records in my data set that are different in some substantial way from the rest of the records or the normal records in the data set. And there are 3 different visualizations that help me do that match different types of modeling techniques. Clustering is one way to understand how anomalies are different than others. And here I can see different clusters that have been produced using a clustering technique for anomaly detection, overlaid by red dots. The red dots represent the anomaly, whereas the gray dots represent more normal distribution or normal records in the data set. So by exploring these different red dots further, I can see that these clusters tend to have more anomalous behavior, and I can try to understand those better. With histogram, this is using a different technique to try to understand differences in anomalies. Here I see the gray bars that represent a normal distribution for BMI or body mass index, and I can see the red bars that overlay a larger proportion of the anomalous behavior within that. For example, the higher the BMI, the more anomalous sort of behavior I have, and I can explore other types of behavior as well. For example, if I want to take a look at the number of children, I can see a distribution that's normal for a number of children. And I can also see where more anomalous behavior occurs according to this data set. The other way is through using a decision tree, or in this case, an isolation forest, to try to understand different anomalies. And I can expand and contract to understand the different anomalies that would be available and the rationale for those anomalies.